Ayo dulu. Aku mau.
We are here, students of Art Engineering Department, Double Degree Program of School of Environment Today, we will explain about integration. Then you all may be confused and you will Okay. Alright, today I will introduce you about the basic definition of integral. Next, this is the antiderivative. Antiderivative is also called integral, and the formula is dfx per dx is equal to fx. Alright, next. Integral is divided into two kind, indefinite and definite integrals. Indefinite doesn't have range to integral the function, and the definite have a range to integral the function. Next. Alright, definite integral is area a curve. Integral is also can calculate the area under the curve. The formula is sigma k is times yk times delta x.
Okay, my name is India, so we move to the next slide. So this is an integral equation or formula used to calculate an area, which is the integral y dx with the range from a to b equals to limit delta x approach dx sigma y times delta x with the k is the value. Next. So definite integral is an integral form whose the integration has limits. Those limits are usually called upper and lower limits. Because the integration variable has a limit, then the definite integral result will be definite number 2. So this is the example for calculating the underlying area. For this example, the integral formula will be integral y dx with the range x1 to x2 is equal to half times y2 plus y2 plus y1 times x2 minus x1.
Alright, I will continue my friend's presentation. And this is the tabulation of integral. This is the main formula of integral. fx is equal to integral fx dx, and this is the definite integral. The function is integral that is have a range fx dx, and then the range is substitute in the function like this. The substitute is will be like this: fb minus fa. Right.
So here this the common integrals, and this the initial, and this the first integral. Like the example, sin ax, and the result is mean 1 per a cos ax. And the second example, cos square ax, the answer is 1 per 2x plus 1 per 4a sin 2ax. And this is the alternate formulation in terms of define the integrals. Phi t equals to integrals 0 from 0 to t a t dt plus v0, and the yt equals 0 to t phi t dt plus y0.
Okay guys, now we gonna talk about the example and application integral in marine technology. Now we give to you 3 example. Number 1 is application in liquid pump. Number 2 is application in center of mass. And number 3 is application in liquid tank. And I'm gonna explain the first one about application in the liquid tank. So this is the question. Find the work that done by pump if we need to fill up a tank with 15 feet length, and the end of the tank make a circle shape with 10 feet radius, and currently tank filled with 7 feet height of water. So we gonna get the calculation right later.
So next,
Okay guys, I'm gonna illustrate the tank draw from the example.
definite integral is an integral of a limit from a to b, like this.
The tank has 15 feet length, and the width from the edge of the tank is 10 feet. There is a liquid with height of 7 feet. So we move this illustrate into two-dimensional Cartesian diagram.
So like previous slide,
Like this.
definite integral is a integral have a limit from point A to B. Like with this picture, we
Yes.
can calculate
Minus 10.
from A to B for
This is the
integral
liquid.
and use the formula. And
This is called delta y.
definite integral, we can use
The width of the tank is 10.
like picture and use this formula.
The height of the tank is 10. Height of liquid
So
is
not
7 feet.
calculate the length, but from
As we know,
definite integral
work
we can
is force times by
formula. But in the formula
distance.
we must calculate
The distance is moved from minus 10 to
S, X, or
minus 3.
we can rotation for
Minus 3 here.
Y.
And the force is weight
And
of the liquid.
formula or properties of the definite integral. We have order of this equation.
So
0
volume
constant
times by
and
density is the force. From this diagram we get the delta work is density times 15 times 2 root of 100 minus y square times by delta y times min y. Oh, I forgot to explain. We got this one from this 100 minus y square root. So we got the equation to integrate is density from minus 10 to minus 3 times by 100 square root of 100 minus y square times min y dy. So this is 15 times by density times min 10 from min 10 to minus 3 times by 100 minus y square in the power of 1/2 times 2y dy. So we get 15 times density times 2/3 times 100 minus y square 3/2 from minus 10 to minus 3. 100 per 3 times 91 per 2 times density, that equals to 1.805.616 feet pound. The density of this liquid is 62.4. So that is the solution of this example. The work we need to move the liquid from the bottom of the tank to the top of the tank in minus 3 here is 1.805.169.616 feet pound.
To find an integral, but only when it can be set up in a special way.
Okay guys, let's move the next question. The density or delta x of a wire at a point located x centimeters from the end of the wire is delta x equals to 3x with power of 2 gram per centimeter. Find the center of mass if the wire length is 10 centimeters. Okay, we will get the calculation letters.
We draw the shape of the wire like this. From the slide, we know that the density of the wire more approach to the one end of the wire is more dense. So to make you easy to understand it, I'll draw some line. Okay, so it said that more we approach the 10 centimeters, it will be more dense. And we know from the picture, so the first x is 0 and the second x is 10. We will use this to make the limitation of the integrals. And from the slide, known that the density or delta x from somewhere point in the wire, we can set it as x bar is 3x with power of 2 gram per centimeter. So we will search about the mass center, or we set it with x-axis of the wire. Now the formula is x-axis is same to m per m is same to integral x Okay, from this we input the value of delta x. Okay, then we do the integral to this formula. Okay, from this we know that the value of the x-axis or the center of mass of the wire is 7.5 centimeters. We look back to the picture of wire. So logically, if there is different density in the wire, the center of mass is more approach to the point that where have a higher density. So we can say that the position of center of mass is here. With which is about 7.5 centimeters. Okay. What the relation of this to the maritime technology? So we know that in the ship we we must make a different thickness of the plate. So in the ship, if the more deeper your shape, the deeper position in your ship, you need deep, more thick wall to make the ship make the ship can resist the force of water. So we can make the decision where is the point of center of mass in the ship to make the location of center of mass is keep under the center of ship. Because of what? Because of why? If the center of mass of your ship are higher than your center of midship, it can make your ship is capsized because the stability is bad. So you can make the stability of your ship is better if you know about this. Okay, thank you.
So I will explain the third question as well as the last question that our group will present. So the question is about a tank that's filled with the water. So the tank, as you can see, the tank has a shape like this, and it will be filled with water with density of 2.4 pounds per feet cubed. And we have to find the total force done by the water to the wall of the tank. And for the calculations,
So let's get to the calculation of the question number 3. First thing we have to do is we draw the tank to the Cartesius diagram. And then by doing this, we have the coordinates, which is at this point it's 0, 0, and at this point it would be 8 and the y is 0, and at this point it is 10, 6. Now, as said in the question, the tank is filled with water. This water has heights, and the height to the water is 5 meters. As if you notice, the tank at the right side of the tank, this is actually a slope where we can find the slope. Slope is this minus this, so it would be 6 minus 0 over 10 minus 8, which is equal to 3. So based on the slope formula, which is y minus y1 equals to x1 x minus 8. So from the data that we have, we can put it here, and we'll get y minus 5 equals to 3 x multiplied by x minus 8, and then we'll have y will equal to 3x minus 24 minus plus 5. Salah.
Sorry gitu. Sorry.
Sorry, I did some mistakes. This is actually a 0, as you can see. it's 8.0. We are doing this part, so it's 0. So we don't have. Okay, so this is the final equation. So if we draw it on the diagram, it's this part, and this will be x equal to 1/3 times y minus 24, plus 24. So the next step we're going to do is we assume that the height from the base of the tank to this part is y. So the rest would be 5 minus y. So with that being said, we can now move on to the force formula. The force formula is density times height times the area. So now we will have something like this. This part, okay, I forgot to mention that. Now we can assume that this part is the delta y. So the formula for force would be density times the height, which is this part right here, minus y, and then times the area, which is the x, 1/3 y plus 24. Oh no, actually it's 8. And times delta y. So we will have so if we integrate the formula, it would be like this: integral 0 to 5 times density times 5 minus y times 1/3 y plus 8 dy. And then if we put the numbers in, we would have something like this. The density, we can put it outside, and then 0, 5, and then just input numbers: 40 minus 19/3y minus 1/3y squared dy. And then we get like, now we have to put these numbers in, which would be 40y minus 19/3/6y squared minus 1/9y cubed, and put 5 and 0. So it would be, if you calculate all these numbers, we will get 62.4 times 100 minus 475/6 minus 125/9, which is 6,673 pounds. So this would be the answer to the question number 3.
Serius? Aku ya, Bay. Iki kok siap dong.